Welcome back, everybody. So in this video we are going to talk about we're going to discuss these questions on Pulley system using Newton's laws of motion. So this question says two unequal masses of 1 kilogram and 2 kilogram are connected by an inextensible string passing over a smooth pulley as shown in that figure. Now, one thing I want you to know about these concepts is that you have to in Pulley system they normally tell us light string passing over a certain body of masses. So when they say light strings, means the masses of these strings are negligible, but there is also a force called tension. I want you to consider yourself, maybe you are this mass hanging maybe on a rope, like this string. You are here and this is the string, right? No, I want you to consider yourself as this string. These things need a lot of imagination. If you're this string and maybe we tie a certain mass on your legs, 2 kilograms, and you're holding somewhere, maybe you're holding on a certain post up there, this mass will be like pushing you right down, right? It will be, so you'll need to have some certain strength. So this string normally has some force called tension force. So there's a certain concept here called tension. You have to know about this tension. So this tension is normally felt in the string. So again, I want you to imagine yourself with the string holding a mass in your legs like that one. You feel a certain tension. Where does this tension pull you? So this tension normally goes up, right? Yeah, this tension is normally up, right? You try to pull yourself upwards so as you can carry this mass. So this force of tension, you normally apply it upwards, and the force of this applying to you, it's the mass called mass here, mg. The mass or the weight now with the one which is going to push you down while you push yourself up with the tension. So this string, it can hold on using the tension is the one which helps it, and the tension here is normally equal to the tension on the other side. Okay, easy. Now what else here? The force pushing down this 1 kilogram block, it's also normally just weight, mg. Also weight is the one which pushes this thing down. If I leave this pen, it will fall down due to weight. It's a mass times gravity acting on it. And then there is this force. Okay, those are the basics. You just know the tension, that this tension here normally equals to this tension here for this set of Pulley system, and it normally acts against the mass so as to be able to carry it, and this muscle weight always acts towards the center of earth, right? Towards down. Now let's read the question. And two unequal masses, yes, these ones are connected by an inextensible string passing over a smooth pulley. That means there's no friction in the pulleys, as shown in this figure. A force of 20 Newton is applied on a 1 kilogram block. Okay, now there's just pulleys like these ones. Then somebody applies a force of 1 kilogram, like pulls this thing down with the force of how many? 20 newtons, right? Pulls this thing down with the force of 20 newtons. On this, they said, is applied on 1 kilogram block. Find the acceleration of either block. Now the acceleration will be the same, because now the thing will be rotating either this direction or this one, depends which force is greater. But we have to assume this part here will have much force, 20 newtons plus this weight. I'm sure it will surpass this 2 kilogram weight, right? So let's assume the whole thing goes this direction with an acceleration a, right? It goes with an acceleration a. I'm taking a lot of time to explain the question, because if you understand the question, the physics part will be done. We'll just go to the mathematics part. Okay, now I think we have everything we need. The physics part is almost going to be done. We just need to apply the principles. Now we need to know from Newton's second law of motion. Here we apply the second law of, which says that the net force, sum of the forces, equals to rate of change of momentum, which is just mass times acceleration. Mv a acceleration change in velocity, rate of change in velocity. Okay, now what's the net force acting in this system? Okay, now let's say this force is going this direction. Okay, so remember, force is a vector quantity, so direction matters. So the force is going to this, taking this thing down here, it's F, right, plus the force on 1 kilogram, okay, which is 1 times, we're given G is 10, mass times gravity. Mass is 1 kilogram, gravity is given as 10. Net force, okay, so the forces taking this system to this direction are done. Which forces are opposing it? This one. You see, this force is pushing this system to go into this to roll into this direction of acceleration, but remember, this 2 kilogram mass is applying weight trying to push it to go this way, right? So I subtract 2 times 10. Now you can say, why are we leaving the tensions behind? The tensions, they just like cancel each other in this case. If you want to find the total net force, again, I can say this tension supports, this tension does not support, so they cancel each other, so no need of including them in this equation. Is equal to mass. What's the total mass of this system? 1 kilogram plus 2 kilogram, it's 3 kilogram times acceleration. Easy. Force is already given here, 20 newtons, so it's 20 newtons. 20 newtons plus 10 newtons minus 20 newtons equals to 3 times acceleration A. So 20 plus 10 minus 20, so that's just 10, right? 10 newtons equals to 3. 3 is 3 kilograms times acceleration. So acceleration will be 10 on 3 meters per second squared. Again, the acceleration the same in this and in this block, you see, so that means find the acceleration of either block. So the acceleration of either block is already given as 10 on 3 meters per second squared. Oh, forgive, I'm writing as somehow slanted writing, but I hope you've understood how we go about these questions. Let's see the next example. Okay, try to pause the video and solve that question. Easy, right? I'm sure you get the answer. Just the same concepts. Ah man, they lowered for you the tensions. Okay, fine. In the system shown below, pulley is smooth, no friction, string is massless and inextensible. Find the acceleration of the system. And I'll have to go straight forward. I'm sure you understood the concepts behind the pulley system questions. So we have, again here we apply the Newton's second law of motion. It's very handy. Newton's second law. This time I'll try to be straight. I've been straight in terms of writing here. So the total force, sum of forces considering the direction, equals to the mass, total mass times acceleration. Okay, now what is the sum of the forces acting in this thing? The net forces. Okay, now we have considered acceleration going towards this place, right, this direction. So the we have mass, this mass taking this thing down here. We have again this mass taking this thing down, this mass taking this thing down in this direction. Okay, now so this acceleration is going, so this thing we have assumed it's turning this way, right? So the total force here, net force, we have this mass here, mg, 6 times 10 newtons, 6 times 10 meter per second. So the total force is 6 times 10 plus again another force which is forcing this thing to go right in this direction, 4 times 10. But we have this one, it's going the other way around. Yeah, they're all going down, but remember that this pulley here, these two forces are making this pulley to turn towards this direction, but this one, it's opposing. It's like telling, hey, let's go towards this direction. So it's decreasing, it's minusing 2 times 10, 2 times 10. So that is the net force, right? Equals to, what's the total mass? Total mass, very easy. The total mass of the system, 6 plus 4 plus 2, right? 6 plus 4 plus 2, I could have just written 12 times acceleration. Okay, 6 times 10, that is 60 newtons, plus 40 newtons minus 20 newtons equals to 12A. Okay, so 60 plus 40, that's 100, minus 20, that is 80. So we get 80 equals to 12A. Okay, now let me put this on here so as you can see clearly. Okay, so acceleration then equals to 80 divided by 12, which is, if you divide that thing by 4, I guess 20 on 3, that is just 20 on 3, that is 20 on 3 meters per second squared. Meter second squared. So that is the acceleration of the system. We already have our acceleration A here, right? Now they need us to find this tension T1 and the tension T2. How do we do it? Easy, right? So we now consider one of the masses, say the 2 kilogram mass here. Let's consider the forces acting on the 2 kilogram mass. Remember, we are narrowing down to 2 kilogram mass because T1 is acting on the 2 kilogram mass, right? Yeah. So let's find T1 using the 2 kilogram mass. Let me write it here. Remember our acceleration is 20 on 3 meters per second squared. Let me adjust here so as we find T1 using this one. Now, the net forces from Newton's second law of motion. Newton's second law of motion is always handy. The net forces here equals to mass times acceleration. Okay. Now, what are the net forces acting on the 2 kilogram block? Okay, what are the net forces acting on it? We have T1, this tension pulling it upwards, and we have this mass pulling it downwards. All right, yeah. So now this acceleration means this body is going towards this direction. That means T1 is greater. T1 wins. That's why it has managed to pull it this way. So we have T1, then I subtract it because I believe T1 is greater. I believe with the mass, I subtract the mass 2 times G, will give me the weight, times 10. Okay, equals to the mass. The mass is just 2 kilogram, right? 2 kilogram times the acceleration. I have the acceleration is 20 times 20 on 3. 20 on 3. So T1 then equals to 20 on 3, that is 40 on 3, minus 20, right? Minus 20 coming in this direction, it will be plus 20. These ones are Newton, this one is also Newton. So if I subtract there, what do I get? If I get T1 equals, I need to use a calculator for this one. So okay, that will give me 100 on 3 newtons. 100 on 3 newtons. That is the tension T1. Easy, right? Now find tension T2. Did you get the answer? Okay, let's do it. Let's find the tension T2. Which mass are we going to consider? Exactly, the 6 kilogram mass here, because tension T2 is acting on the 6 kilogram mass. But we can also consider the 4 kilogram mass, because it's also acting on this thing, right? Yeah, it's kind of complicated, but I want you to understand. If we consider the 4 kilogram mass, let me draw something here. This tension on the 4 kilogram mass, this is the 4 kilogram mass, right? The tension T1 pull this thing upward, and the tension T2 will pull this thing downwards. But if you consider the 6 kilogram mass, let me draw it here. The 6 kilogram mass, if this is the 6 kilogram mass, tension T2 acts upward, then downwards there's just mass. Here there is also plus mass weight mg. What? Complicated, right? No, it isn't complicated at all. It's very easy. I want you to shrink yourself and imagine yourself as this 4 kilogram mass, right? You are the 4 kilogram mass. You are holding on to a string which is attached to a pulley, right? And then there is another string which is attached to another person here down here, trying to hold on to your legs, maybe with a certain string down. Hey, carry me, right? What will you be feeling? First, you'll think the T1, the tension T1 on the string will be the one holding you not to fall down, right? So technically, it's pulling you upwards towards this pulley, right? This tension T1 which you're holding on not to fall down, that means it's producing, it's exerting a force onto your body, pulling you upwards so as you do not fall down, right? So T1 understood, that's why you consider it acting upwards. But the tension T2, that person holding you, this 6 kilogram mass tied to you from below, hanging down below, you'll be feeling it pushing you downwards, right? You'll be feeling like it's applying some force on you to go downwards, like it's pulling you downwards with its weight, right? So that's why tension T2 on the 4 kilogram mass, it's assumed to act downwards. But on the 6 kilogram mass, again, imagine yourself when you are the 6 kilogram mass. You're the one now holding this person. This person, if you're this person, you'll see yourself that this string is the one supporting you not to fall, right? Hey, hold me. You are here telling this guy to hold you. That means this tension T2 on the string, it will be in your favor. That means it will be the one lifting you up. So that's why the tension T2 on the 6 kilogram mass goes upward. But on the 4 kilogram mass, feels as if it's pulling it down. I think you have understood that analogy. The thing about these strings and everything, you just have to assume yourself in one of the masses. How will the string be? How will you be feeling the strings? So to find the tension T2, let me use the 6 kilogram mass because it just has T2 minus mg and things like those. But because this system is assumed to be falling in this direction, that means this guy's mass is way heavier than the tension to help him not to fall down. So that means the net force on this thing, so let me separate that one there. So the net force here, I want you to understand, that's why I'm using a lot of explanations. Then Newton's third law, net force equals to mass times acceleration. But remember, the net force of this one, because acceleration is going downwards, that means this guy's mass is heavier than the tension to make him not to follow this direction, right? That means mg is greater than mg, then we minus tension T2, right? Tension T2 equals to the mass, its mass times the acceleration. You already have the answers. What's the mass of that thing? 6 kilograms. 6 times g, we are taught to use 10, minus tension T2 equals to the mass of that thing is 6 times the acceleration. Acceleration, we had it here as 20 on 3 meters per second squared. So that is 60 minus T2 equals to, by 3, 1 by 3, this is 2, so 40, right? I think I'm correct there. Okay, so this thing T2, what will be T2? That means T2 here, giving you T2 equals to 60, these are newtons, minus 40 newtons. Let me adjust here so as you can see what I'm doing. Okay, so tension T2 equals to 20 newtons. So that's tension T2, tension T1, and that is our acceleration. Okay, easy, right? So it's just all about imagination, like how Albert Einstein used to insist. Okay, let's see. You are told in the arrangement shown in this figure, like that one, find the ratio of the tensions in the string attached to the 4 kilogram block, so the tension in this string, and that attached to the 1 kilogram block, so the tension in this string. Find the ratio of this tension to this one. I'm not going to do this one for you. I assume you have already understood. I'm sure you have already understood. So take your time, solve this question, and not only this one, a lot of questions concerning these ones. I'm sure you'll be flexible to understand these questions. And if you get the answer, make sure you explain it and write it in the comment section. I'll be there to check it. Thank you very much. Make sure you subscribe to my channel. See you in the next video.